What is up, YouTube? And welcome back to episode 14 of the Chaos Daily. We have a particularly interesting topic. It is a topic of great weight. There's a lot of mass behind this topic. That is, of course, because we're talking about weight and mass. And specifically, how heavy is the Long Easy? So, yesterday, Jotham, aka TTN, in our exclusive Legion Discord, brought up the topic, how heavy is the Long Easy gonna be? And I had to think about it, because I hadn't thought about it. So I had to think about it. So I thought about it, and I pulled a number out of my ass, like I normally do, which was around about 1 kilogram. It seemed reasonable to me. But is it gonna be 1 kilogram though? And there's a couple of factors we have to take into consideration. What material are you gonna make it out of? Are you gonna use resin, in which case it has a specific gravity of 1.1 grams? Or are you gonna make it out of PLA, which also has a specific gravity of about 1.2 grams? It's a little heavier than resin. Shock, I know, horror. Or are you going to use lightweight PLA? You know, the foamy stuff? Yeah, that has a ridiculous specific gravity of 0.4 grams per cubic centimeter. Really? Try hard much lightweight PLA? Try hard much? Can't you just be like the other plastics? Anyways, but there are some key caveats here, and that comes down to manufacturing process. With FDM printing, you have to print it a certain way, because otherwise the print takes forever, or you use too much material and it's too heavy, or it won't stick to the bed, or you can't just print in midair. There are little details you have to consider when printing. This is the same for resin, this is true, but you can get away with a lot more. And when I say you can get away with a lot more, I really mean you can get away with a buttload, because, oh boy, you print the whole layer all in one go. In FDM printing, that print head has to come along and print everything. And if you want to put lots of holes in your internal structure to lighten it up, it has to stop, lift, travel, go down, start printing again, lift, travel. This adds a ton of time to your print time. It will double your print time easily, if not triple it. I've done my own printing. I know what plastic printing's like. It's a pain in the ass, and it's awesome, but it's pain in the ass. Resin printing, I mean, I can't speak from experience because I haven't done it yet, so I'm just going off what I've learned. And what I've learned is you can get away with a lot more, and it's a lot more forgiving, and there are things you can do with resin printing you simply just cannot do with plastic printing. And one of those things is putting holes in everything, making stuff hollow in weird places, just some banana stuff you can do to the internal structure to reduce the weight without losing that structural integrity. Now, because resin has a much different material property to plastic, whereas plastics, they generally yield, they bend, and they go to a certain point, they become deformed, which means they will not yield back, they will not bend back. That's their failure mode. With resin, you keep applying pressure, it breaks, right? There's no in between. It's either working or it's exploding. People like exploding stuff. I like exploding stuff. Anyways, so yeah, but that consideration means that it will be strong to the point it fails. And whereas plastic, it will bend and give a little bit, which is great for an airframe. But when you design your structure in a certain way, that it will transfer stresses through the structure so that there are no points along the structure where it will have a weakest point or a failure point. So you transfer your stresses to the point that will take the load, and that'll be your carbon fiber spar. So designing the internal structure for a resin print is fundamentally different to designing the structure for a plastic print. So I will have to make multiple vials of different things for different stuff, and it's going to be a lot of work, but it's going to be well worth it, because one of the key things I'm trying to bring to the table with resin printing is to say, yes, okay, I know, it's hella expensive, but can your plastic do this? And that's what I'm trying to achieve here. It's more of just, have you considered this? Have you looked at this? Have you given this its full consideration, right? And that's what this is about. So let's jump into Inventor, and I'm going to show you some numbers, and we're going to look at some differences. It's a bit of a disclaimer, because most of the plane isn't finished yet. I can't give you specifics for everything, so we're going to have to make estimates, but based on what I can tell you, it's a very good rough estimate. And another disclaimer, things are subject to change. Results may vary. It could well be different in a week's time, so just keep that in mind. But the numbers shouldn't change too much, hopefully. So let's jump into Inventor. So let's have a quick look at it. Now, at the moment, I have the generic default materials property applied to this model. But that's handy because I can just come in here and select generic, click edit, go over to physical, and in here in physical, I can set the specific gravity of something. Density, 0.4 grams per cubic centimeter. So I've got it set for the specific gravity of PLA, specifically lightweight PLA, the foamy stuff, the show-off stuff. Anyways, right? Specific gravity set. These are not all the parts of the plane, obviously. I've hidden things like the canard tips, the wing tips, the main body, the ailerons. The reason being is that they have not been hollowed. The shell tool, it's a bit finicky sometimes. It has issues, right? I don't think the shell tool, had a good relationship with its father when it was younger. There's just something about it. It's not right. Anyway, moving on. So these are all the parts that have been hollowed and all the parts that have internal structure. So essentially, they're done minus any holes for spars, push rods, yada yada, all that stuff, right? So they can still essentially be lighter than what they currently are. Keep that in mind. They could still be lighter than what they currently are. So selecting all of these parts, we can right-click Properties, and we get a weight. So now just take a seat. Take a moment to look at this number, right? This number right here, 0.148 kilograms for all of the wings and the canards. That's less than 200 grams for the wings and the canards. So taking that into account, we add, say, maybe, I don't know, another 100 grams for the wing tips and the canard tips, right? Because you'll hollow those in your slicing software, right? I'll just add the structure for the spars and stuff, and in the slicing software, you would go in and you hollow it, and you just do your wall thickness, and you maybe have an infill for some structural integrity, but generally, you can expect the tips and the canard tips to be around 100, let's say 150 to be generous. So now we're up to 300 grams just for the wings, including the tips. Now, if we take into account for the body, now because it's very large, you'd think, oh, that's going to be really heavy, but it's going to be mostly hollow. There's going to be far less structure in the body than the wings. And the reasons for this is tubes transfer stresses along their surfaces differently to wings, right? Wings are mostly flat area surfaces. They bend in different ways. A big tube, or basically the body of the aircraft, it can take more stress, right? Without having as much structure. So the whole body, let's be generous, let's say 400, maybe 500 grams. Now, we're talking 800 grams for a aircraft that's what, 1.4 meters in wingspan? That's impressive. That's going to be impressive, right? I mean, let's put the wing tips back in so I can grab a number there. And look at that, 1.46 millimeters, right? That's basically 1.5 meter wingspan. This is a fairly sizable aircraft when he created a monster, and it was just tortured by the people. I'd never read Frankenstein, so I can't really say. I'm just pulling that out of my butt. Anyways, right, so that's lightweight PLA. Now, here's one I prepared earlier, a materials property for Soraya Tech Blue. This is what I've been using on the Draco to get information on the material properties and everything. So let's just go through and hide those wingtips again, because oh boy, it'll be heavy if you just calculate a solid mass like that. These wingtips probably weigh more as they are now than all of the rest of it. In fact, one of these probably weighs more than all of these combined. Right, so we've got those all hidden. I'm going to run through and select them all again. Properties. Ooh, look at that. 400. Quite a bit heavier. That's not so good. What's going on here? But now remember, I mentioned with resin printing, I can cancel out maybe 50% of that weight. So let's say 200 grams. Because all of that internal structure is solid. I need to fill all of that with holes, right? I need to lighten the crap out of it because I don't need it. The material transfers stress differently. It doesn't yield. So I don't need to have reinforcing material behind material behind material to transfer stress because it's not yielding. It'll just run along the surface through the material and transfer wherever it distributes. So yeah, we can say maybe the resin version will be 30% heavier. So yeah, there you go. It's going to be literally 1.04 kilograms, right? So 1,000 40 grams. That's so now that's some impressive stats, right? This thing's going to be pretty good. Well, I'm hoping so. That's what I'm working to. But now here's some key things to remember. Remember how I've been going on about the material difference between resin and plastic, how plastic yields and bends, and resin generally just snaps when it reaches its breaking point. What happens when you mix resin with carbon fiber? We all know how strong carbon fiber is, right? This same aspect applies to a resin printed part with a carbon fiber rod through it, or a carbon fiber tube through it. It transfers the stresses directly to the carbon fiber and doesn't have the opportunity to reach its yield point where it snaps. The carbon fiber takes the load. So it has all the benefits of being a fully carbon fibered form without the drawbacks of being that expensive. Well, maybe, the resin printer is quite expensive and the resin's quite expensive, so it's pretty close in the runnings. Yeah, probably. Anyways, so considering the differences, with lightweight PLA, you have to have more structure, more mass in your structure in order to transfer stresses to your carbon fiber tubes and your other load-bearing structures. With resin, it transfers that energy far more efficiently to your load-bearing structures. You have far lower yield and bend and deform rates, which means this plane will outperform in resin than it will in lightweight PLA. I'm going to make that claim right here, right now. The resin version will have far better acrobatic and G-force loading characteristics than the lightweight PLA version, or even a PLA version. And I will say that right here and now, and if you agree with me, let me know. If you disagree with me, jump down in the comments and let me know. I want to hear about it, and let's get this discussion going, because this is an engineering and materials properties thing that we need to just explore and discuss, because that's the whole point of this whole thing, is to go, hey, what's the difference between a resin printed plane and a plastic printed plane? And I hope to see you all there in that journey with me the whole way through. So, I've been Chaos, and as always, expect the unexpected, and I'll see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.